2 by 2 matrices, determinants, and inverses. Up here we have a definition, several definitions. Go ahead and write down the definitions. Square matrix is what we're going to be looking at. You have a matrix with the same number of rows as columns, so you have a 2 by 2 in this section. Next section we'll do a 3 by 3. So anything with the same rows and columns is a square matrix.
Are the ones diagonal in the 3 by 3?
Say that one. We haven't gotten to that yet. That's the identity matrix. That's your next definition. You have a 2 by 2 identity matrix. Write that down. The entries would be 1, 0, 0, 1. The identity of a 3 by 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So basically, whenever you have the identity matrix, all of your entries need to be 0, except from top left to bottom right, where they are positive 1 all the way down. Okay, so a 4 by 4, you would just add another row and column. You put a 0 here, 0 here, 0 here, and then 0, 0, 0, 1. That's the identity matrix.
Are they all of these going to be the same number? Like
Always 1 and
5 by
always.
5?
Yeah, it's always a square matrix for the identity. And down here, this symbol right here, if you have matrix A times A to the negative 1, A to the negative 1 is your inverse matrix. Okay? And we'll get to what the inverse matrix is in a second. But when you multiply a matrix by its inverse, you will always end up with the identity matrix. So the first example we're going to look at is where I'm going to give you two matrices, and you have to show that they are inverses of each other. To do that, you multiply them together and verify that you end up with the identity. Okay, everybody got all this down?
So with identity, you can only use 1 and 0?
You end up with 1, 0, and 0, 1 for the identity. All zeros and ones, yes.
Thank you.
Okay? Alright, so this example, we're going to verify that these are inverses of each other. And you only have to multiply them in one order. You can either do A times B or B times A. It doesn't matter. Okay? If it works one way, it has to work the other way. So if I multiply A times B, which I did here, just like we were doing last night, in multiplying matrices, you take the rows of the first, columns of the second. Okay? When I multiply this matrix by this matrix, I should end up with this. When I simplify it, I end up with the identity, and that shows that A and B are inverses of each other. Okay, all we're doing right here is verifying that two matrices are inverses. We're not actually finding the inverse yet. We'll get to that in just a second. Yes? Okay?
If they're an inverse, they always end up having 1, 0, 0, 1.
Two inverses
Yeah,
multiply to get the identity. And make sure you're clear on how to multiply. We still had questions in the last class about how to get each of these entries. So make sure we're okay on that. Okay? The determinant of a 2 by 2. This is another definition. Write it down. Pretty basic. Determinant of a 2 by 2 matrix. If we have matrix A equal to A, B, C, D, then to find the determinant of matrix A, all you do is multiply diagonally A times D and subtract C times B, the product of C times B. So know that formula.
What if you have a 3 by 3?
We'll get into that in the next section. We're only doing 2 by 2s right now. Yeah, 3 by 3 is fun.
I'm sure.
So excited.
It's not as easy as that. Alright? So let's look at an example. Everybody have the definition down? Hold on. Okay. Alright, so here is matrix A. To find the determinant, all you do is multiply diagonally. Negative 3 times negative 5 is what?
15.
15 minus 2 times 4 is 8. So what's your determinant?
That's it.
7. That's it. You'll get a single number for the determinant.
And what is the determinant mean again?
We're going to use that in finding the inverse, which we're about to do next. And in the first example we did, we just verified whether two matrices were inverses of each other. Now we're going to actually find an inverse. So if I only gave you one matrix and told you to find its inverse, we're going to need to know how to find the
So
determinant.
inverse times inverse, or two inverses are equally identical.
Yes. They have to multiply to be the identity. To show that they are inverses. Okay? Alright, so the inverse of a 2 by 2, write this down. If you have a matrix A, which same matrix we just took, A, B, C, D, then its inverse, A to the negative 1, means inverse, is equal to 1 divided by the determinant. Just write it down. 1 divided by the determinant. And then you have to alter this matrix to this. So the inverse is equal to 1 divided by the determinant. D and A switch. B and C stay where they are, but you negate them. And I probably will end up giving that to you. So don't worry. And you'll see in the example of how to do it. It's not that complicated. We already know how to find the determinant. We just did in the last example, find the determinant. Before you ask a question, wait till we get to the next example. Just write down the formula. Okay?
Wait,
A negative 1 is the inverse, right?
Yes. A to the negative 1 is the inverse of A. Yes.
when we were figuring out the determinant, you do A times D minus C times B?
Correct.
Okay.
Multiply diagonally. Okay?
Is it always minus or will it be like?
Always minus.
a check?
Well, I mean, it could end up being a plus if your product is a minus, because a minus of a minus is a positive.
Okay.
Yes.
For the C and B, you always just turn them into negatives.
Correct. You leave C and B where they are and negate them, switch A and D. Don't
And then-
change the sign.
And then for 1 over D, A, what you always put that there. That's just part of the formula.
This is 1 over the determinant, DET, of A.
And then you always put it there.
Mhm.
Okay.
Yes, your determinant has to go here. All right, let's look at an example. All right, so if you have matrix M equal -2, 2, 5, -4, find its inverse. So we start out by doing 1 over the determinant. How do I find the determinant? Right here. You do -2 times -4, right? Which is 8, minus 5 times 2, which is 10. So what's your determinant? -2. So that has to go here. 1 over the determinant. Any questions so far? Right there. Okay? And then all you have to do is switch these two, -4 and -2. Leave these two where they are, but negate them. Okay?
Negative just means make it negative.
Change the sign. So if they started out negative, they become positive. Okay?
Why is it, oh, never mind.
All right, and then -1/2 is your scalar. So I do -1/2 times -4 to get 2. -1/2 times -2 is 1. Positive 5 halves. Positive 1.
So the bottom matrix is the inverse of the first one.
Correct. So, yeah, this is the inverse of the first. So if you were to multiply these two together, what do you end up with?
0, 1, 1, 0, 0, 1.
Correct. You end up with the identity. 1, 0, 0, 1.
If you were to multiply which two together?
The original, right here, and your inverse. You should end up with the identity.
Oh, your original and
Can
then
we
your
check that to
answer.
see if it's right?
Yes, we will.
So like the original and then your answer is the inverse.
Say that one more time.
The original and then your answer is the inverse.
You have the original and you found the inverse.
Oh, there it is.
Okay? All right, now, this formula you're really gonna like, especially towards the end of the chapter. Solving any matrix equation. We've already solved matrix equations in the form of addition and subtraction. So if I have capital A plus capital X equals B, we know how to do that. Okay, but this is new. Capital A times matrix X equals matrix B. If you have anything in this form to solve for matrix X, you have to do A inverse B in that order. It's just like solving any equation. How do you get X by itself here? Divide by A, but you can't divide matrices. So instead of dividing by a matrix, you multiply by its inverse. Same thing. Okay? And it has to be in this order. Don't do B A inverse. It has to be A inverse B. All right, let's look at the example. So know this. Know how to solve any matrix equation with multiplication.
Isn't that what we've been doing though? Like,
No, the matrix equations we've solved before were just addition and subtraction.
no, but what we learned yesterday was multiplying matrices.
Right.
So what is?
Well, we're just going now, the new part is going from here to here. So it's, I mean, you
Finding
know
the
everything.
inverse?
You know how to find the inverse and you know how to multiply. Now just put it all together. So here if I have this matrix times matrix X equals this matrix, solve for matrix X. Okay? I labeled this A and this B. Then I found the determinant of A. Determinant of A was -1. Switch these two, negate these two. -1 is my scalar, so this is the inverse matrix. Then I took the inverse matrix and multiplied it to the B matrix. And I should have ended up with -4, 2.
How'd you get the box under B?
Under B,
Yeah,
this,
yeah.
I multiplied -1 times each
Okay.
of these.